Hi everyone. Now let's solve this rotational motion question. Now, yes, this is a question about a ball, okay, on the end of a rope that is swing horizontally. So now let's see how we can solve how this question can be solved. Okay. Now the question reads: an athlete swings a 5.0 kilogram ball horizontally, okay, on the end of a rope. Okay, so the ball moves in a circle of radius 0.80 meters at an angular speed of 0.5 revolutions per second. Now we have here that we want to find out what are the tangential speed of the ball, okay, and its centripetal acceleration. Now the third question is that if the maximum tension the rope can withstand before breaking is 100 Newton, what is the maximum tangential speed the ball can have? Now for a question like this, okay, it is important, to draw a free body diagram, to analyze the problem. Okay, free body diagram most of the time helps, it helps to explain the question and also to navigate through the solution. So now let's see how this can be solved. All right, so now let's have our solution. So let's talk about the free body diagram. So the first thing is to what is to draw a free body diagram. Okay, we draw a free body diagram. So let's say we have a ball. Okay, now the ball is on the end of a rope when it swings horizontally. When an athlete, swings the ball, the mass of the ball is, this is the ball. The mass of the ball is 5 kilograms. So we have mass of ball to be 5.0 kilograms. Okay, now so this is the ball on the end of a rope. Now let's analyze the forces that will act on the ball. Now when at equilibrium, before the ball is set into circular motion, before it swings, when it swings, the body moves in a circle of radius 0.80 meters. So what that means is that now when we have the ball in equilibrium, okay, now two forces will counterbalance each other. One of them is the normal force, okay, which is the upward force acting at right angle to the surface of the object, which is the ball. Okay, now this force will be counterbalanced by a downward force, which is also the weight of the ball. Weight is the gravitational pull on an object, okay, or on a body towards or near the surface of the earth or center of the earth. So we have the weight. This is the weight. Now the weight will be equals to force of gravity, and that will be equals to mass times gravity. Okay, now the ball swings. Okay, the ball swings, that is, the ball describe a circle. Let me draw it this way. The ball describe a circle. So when the ball describe a circle, as it describes the circle, there will be a force that will keep the ball moving in a circle along its path, and that force will develop an acceleration on the ball. This acceleration is what we call acceleration known as centripetal acceleration. Okay, so that's why we're also going to calculate the centripetal acceleration. So when the force keep the body moving in a circle, it will develop an acceleration, and the acceleration is what we call centripetal acceleration. Now what is now the tangential speed? That is a linear speed, okay, which will, just like, let me draw the, now it keeps the body moving in a circle. That means there will be a radius. Let's say this is the center of the circle, so we have r to be 0.08 meters. So because the force keeps the body directed towards the center of the circle along which it moves, so we can say that the force is Fc, which is centripetal force, and this force will be what? mv square over what? r. So we can have v, which is the tangential speed, to be what? So this is the tangential speed. That is, it is the speed, okay, a body is said to undergo or execute circular motion when it moves with a constant velocity, okay, a constant velocity, okay, as it describes a circle along its path. So which is what we have here, v. So we have the tangential speed. Then because I said, remember I said this force will develop an acceleration, and we have fc equals to mv squared over r. So that means the centripetal acceleration, okay, we're going to have the centripetal acceleration. It will be directed towards the center. That will be, so the direction of the centripetal acceleration, this is the centripetal acceleration, okay, that will be AC, okay. So that's centripetal acceleration. So first thing first, we want to calculate the tangential speed, and we're given the radius. We're given the radius of the ball, which is what? 0.80 meters. Okay. Now, what again are we given? Now, we're given the what? The angular speed. Now, for the angular speed, let me use this to represent the direction of the what? Of the angular speed. That's the direction, it moves. That is the angular speed. Okay. So we have, this is the angular speed, W, and that is 0.5 revolutions per second. So we have W, okay, that is the angular speed. The angular speed, okay, which is W, is what? 0.5 revolutions per second. Okay, so now, what else? Okay. So now, let's solve the question accordingly. So the first question is for us to what? To calculate the tangential speed of the ball. That is the linear speed. So we can say let V equals to what we call tangential speed. So this is the tangential speed. Now, there's a formula that can relate, yes, there's a formula connecting tangential speed or linear speed with what? Angular velocity. So that means linear speed or tangential speed can be related with angular velocity by the formula V equals to RW. So this is the formula, relating angular speed with what? Linear speed. Now, we have angular speed. Now, the angular speed we are given here is in revolutions per second. And we know that the unit for angular speed is the what? Radians per second. So we need to convert this value from revolutions per second into what? Into radians per second. So note, okay, we need to convert the angular speed from revolutions per second into what? Into radians per second. Now we know that one revolution is what? 2 pi radians. One revolution is 2 pi radians. So which means the angular speed will be, now we are given angular speed to be 0.5 revolutions. So we have 0.5 revolutions per second, okay, multiplied by 2 pi radians, okay, 2 pi radians per revolution. Yeah, 2 pi radians per revolution, so that this will cancel out. So we'll be left with 0.5 times 2, that will be 1. So we have 1 pi radian per second. So the angular speed will be 1 pi radians per second, or we can say it is what? 3.142 radians per second, because 1 pi is the same thing as what? 3.142. Okay, so now we now know the value of W in radians per second. So now let's calculate the tangential speed. So we know that V equals to RW. R is 0.80 meters. So we then write V equals to 0.80 multiplied by 3.142. Remember, the unit of speed will be what? Meters per second. That is linear speed. So we have 0.8 multiplied by 3.142. Okay, that will be 2.51. So the velocity is 2.51 meters per second. Okay, this is the tangential speed. Okay, the tangential speed of the ball, which is the first question. Now let's talk about the second question. Now, the second question is to what? Is for us to calculate the centripetal acceleration. Now, to calculate the centripetal acceleration, the formula for centripetal acceleration is, now I can say let AC, we have AC here already. AC equals to what we call centripetal acceleration. okay, centripetal acceleration. So that centripetal acceleration will be v squared over r, or we can also make use of w squared times r. That is angular speed raised to the power of 2 multiplied by radius. But because we just calculated the value of v, which is the tangential speed, so let's make use of this value, and already we know that the value of r, which is the radius, okay, of the circle, the ball describes when the force, when the centripetal force, keeps the ball moving in a circle, all right, okay, in order to develop an acceleration, which is what we call the centripetal acceleration. So we can say that AC equals to 2.51, okay, raised to the power of 2 over what? 0.8080. Okay, so when we have 2.51 raised to the power of 2, that will be 6.318. So we have AC to be 6.3182, okay, divide by 0.80. Okay, divide by 0.80, that would be 7.898. So the centripetal acceleration is 7.898 meters per second square. Okay, meters per second square. That is centripetal acceleration. Yes, sometimes, let's say we want to use the other unit, that's the radian per second square. It is important for us to know that for circular motion to occur, okay, without centripetal force, circular motion cannot occur. That means a body will not describe or will not move in a circle when there is no centripetal acceleration. Centripetal acceleration that will be developed on the body when a force known as centripetal force acts on the body. Let's put it that way. Okay, all right. So the third question now, we have here that if the maximum tension the rope can withstand before breaking is 100 Newton. Okay, so what is the tangential speed the ball can have? Okay, so all right, so if the maximum tension the rope can withstand before breaking is 100 Newton, okay, so what is the maximum tangential speed the ball can have? So that means that the maximum tangential speed the ball can have will be when the tension, okay, when the tension provides the centripetal force, okay, that will be required to produce the tangential speed. That is the centripetal force that will be required, okay, to keep the body moving in a circle. Yeah, so that is, when we talk about tensional force, we can have something like this. Okay, let's say this is the object. Okay, so we have the downward force, W equals to mg. We have the normal force. So if there is a tension, okay, we can also have linear speed in this direction, but let's say we have a tension. If there's a tensional force, so in this case, that means T will make some angle with the vertical. This is not the case here. All right, but there's no angle. They said if the tension is maximum, okay, the maximum tangential speed, the maximum tangential speed the ball can have, okay, when the maximum tension the rope can withstand before breaking is 100 Newton. So that means, so now I just want to explain this. So let's say this is alpha. So by resolution, we can resolve this horizontally, okay, and we also resolve vertically. So here, this will be Ty equals to T cos alpha. While here, this will be Tx equals to T sine alpha. Equals to T sine alpha. So when the tensional force makes some angle, makes an inclination with the vertical, so that's what we have in this case. Okay, so now then we know that the direction of centripetal acceleration will be towards the center of the circle. So we have here that this is the radius of the circle. So at the same time, the direction of the centripetal force, so this will be equals to the centripetal force in this case. Okay, but here, that is when the tension is maximum. So now we are now giving the maximum tension. The maximum tension is given to be 100 Newton. Now let me not talk much about this because if we continue with the resolution, it's going to be time consuming. So the best thing is, okay, to understand why the rope before breaking, okay, the rope can withstand a maximum tension of 100 Newton. That means before it can break, the tension the rope can withstand, okay, the tension it can withstand is 100 Newton. So anything above 100 Newton, then the rope will break, okay. So the velocity, which is the maximum velocity known as the tangential speed the ball can have when the maximum tension is 100 Newton, because this maximum tension, okay, will provide the centripetal force required, okay, to keep the ball moving in a circle. And in this case, so we can say that Tmax equals to Fc, and that equals to mv square over what? Over r. So don't forget, this becomes that's v max to the square, because we are looking for the maximum tangential speed. Remember, we are not giving angle of inclination, okay. I only use this to explain, we have so many ways the diagram can be can be drawn, okay. So this is one way, okay, and then this is another way, okay. So but when we have the angle to be, when the angle which t makes, let's say t makes angle theta with the horizontal, then this becomes tx equals to t cos theta, and this becomes ty equals to what? T sine theta. Okay, when the angle is theta, that's when the inclination is with the horizontal. But in this case, we have it to be vertical. But I only use this to explain the case of tension. There are questions about tensional force when it comes to a body moving in a circle, whereby we'll be giving the tension to make some angles with the wall, either with the horizontal or with the vertical. So we have this. So now let's rearrange this equation so that Vmax can be equals to, so we have Tmax times R over what? Over M. Yes. So that is the formula for V. So now the formula for V, so we have Vmax to be equals to the square root of the tension is what? 100. Then multiply by the radius. The radius is 0.80. Then divide by the mass of the ball. That will be what? 5. Okay. So we know that 100 divided by 5 is 20. So we have the maximum tangential speed to be the square root of 20 multiplied by 0.8. So 20 times 0.8, that will be 16. Yeah. So we have the maximum tangential speed to be the square root of 16, and the unit is what? Meters per second. So we can say that the maximum velocity, which is the maximum tangential speed, will be 4 meters per second. It will be 4 meters per second. So this is the maximum tangential speed. Please don't forget that I said, note, the maximum tension, the rope can withstand, will provide the centripetal force, which is Fc, required, okay, to keep the ball moving in a circle. So that means the maximum tension will be equals to the what? Centripetal force. So that is the point I am trying to make here. Okay, that's why we have Tmax to be equals to Fc, and we know Fc to be what? Mv max square over what? R. Okay, and the value of the maximum tangential speed that the ball can have is what? Is 4 meters per second. The noblest pleasure is the joy of understanding. Bye bye.